Hey everybody, it's Mr. Mott. What I want to do is talk about how fractional crystallization works. All right, so let's say that we had 30 grams of KCl and 30 grams of KClO3 dissolved in 100 grams of water, and let's say that we are at 80 degrees. Okay, so again, 30 grams of each. My data point is going to be right here on our graph if we're at 80 degrees here. And we're going to notice for both of our substances, KClO3, I'm below the line, and KCl, I'm below the line. So what that means is that I have an unsaturated solution of each. Now we are going to make an assumption here that the solubilities of KCl and KClO3 are not affecting each other, and also they're not interacting in any kind of weird way. So in fractional crystallization, one of the things that you would do to remove some or all of one of our solids would be to cool it down. And so what I would do if I was going to cool this down, if you think about how my data point would be moving, it would be moving to the left here. And as I got to where I'd crossed this line here at around 65 degrees, I would reach the saturation point for KClO3. Now, at 65 degrees, all of my KClO3 will still remain dissolved. However, if I go below that, I am going to be sort of above my line, which is really telling me that all that 30 grams that I had dissolved, well, all of it can't stay dissolved. I would have to be at 65 degrees or greater for all of my KClO3 to remain dissolved. So as I cool it down, let's say I cool it down all the way to 10 degrees. I'll choose a little different color so we can kind of see it a bit better. So let's say I cool this down to 10 degrees. At 10 degrees, for KClO3, I can only maybe dissolve about 5 grams of KClO3. So if I cool my 100 grams of water down to 10 degrees, only 5 of my original 30 grams could be dissolved. So what would happen is that 25 grams would precipitate out of solution. In other words, you would see crystals forming in your solution, and we can be confident that all those crystals that form are KClO3. Because if we compare that to KCl, which is the data point that we have up here, at KCl at 10 degrees can dissolve 30 grams of our substance. Okay, that's where our line hits. So at 10 degrees, all 30 grams of my KCl would remain in solution still. I haven't gone sort of past that point of solubility. All right. So that's kind of how fractional crystallization works. You take advantage of the different solubilities of different substances, and by cooling them down, you're able to precipitate out one of your solutes, while the other solute remains in solution. All right. Thanks for watching.